Okay, so in the last lecture we looked at geometric progressions and we looked at few of the formulas for the same. So basically we found out how to find the nth term of a geometric progression. The formula used was a raised to power n minus 1. For the sum of n terms of a geometric progression, we used a into r raised to power n minus 1 upon r minus 1. Then for the geometric mean, we use the formula. It is the nth root of the product of n terms of the GP. So these were the three things we looked at. Also, we saw that arithmetic mean of n terms is always greater than the geometric mean of n terms. So we should remember this, as this may be used in some maximum minimum kind of problems. Now here in this lecture we are going to look at what is the sum of an infinite GP. So first thing, what is an infinite GP? Now suppose the first term of a GP is A, second term is AR and AR square and so on. Now this goes till infinity. So what will be the sum of these infinite terms? A plus AR plus AR square and so on till infinity. Now we know the sum of n terms of a GP is A into r to the power n minus 1 upon r minus 1. Now clearly this sum will be finite only if r is less than 1. So mod of r should be less than 1, otherwise this sum will go to infinity, because if we keep increasing the terms, if suppose the first term is 2 and let r be also equal to 2 and we are finding the sum 2 plus 4 plus 8 plus 16 till infinity, this will come out to be infinity only. So therefore sum of an infinite GP is always found for mod r less than 1. So the value of the common ratio should always be less than 1. It could be 1 by 2, 1 by 3 and so on. It has to be less than 1. So less than 1. Now sum of n terms could also be written as a into 1 minus r to the power n upon 1 minus r. So I'll just change the signs in both numerator and denominator. Now for infinite terms n tends to infinity and we know that r is less than 1. Modulus value of r is less than 1. So what does this mean? As n goes to infinity, Rn will go to 0. Okay, because the nth power of a very small number, and because limit of n tends to infinity, r to the power n is equal to 0 for r less than 1. So therefore r to the power n, so therefore if we find out limit n tends to infinity Sn, this could be computed as a 1 minus r to the power n goes to 0 upon 1 minus r. This is equal to a upon 1 minus r. So this is the formula for the sum of infinite terms of a GP. So let's look at an example. Let's take a GP of 2, 1, 1 by 2 and so on till infinity. So here the first term is 2 and the common ratio is 1 upon 2. Basically we are multiplying it by 1 upon 2 every consecutive terms. So now to find the infinite sum of this GP, we will have S infinity equal to a upon 1 minus r, which is 2 upon 1 minus r is 0.5, this is 4. So sum of this infinite GP is nothing but equal to 4.